AI is absolutely everywhere these days, isn't it? I mean, from helpful chatbots to those really complex recommendation engines basically shaping your whole online world.
Yeah, it's unavoidable.
But I often find myself wondering, how truly intelligent are these systems? Do they really get it? Do they understand context or even think about ethics?
That's the million-dollar question.
Exactly. What if we could build AI that, well, goes beyond just crunching data, something that maybe gets closer to genuine wisdom?
Uh-huh.
So today we're doing a deep dive into something called Sophimatics. It's a concept from Gerardo Alvan and Giovanni Alvane, and they're presenting it as, well, the science of computational wisdom.
That's right. And its core mission is exactly that, to be the science of computational wisdom. It tries to do this by weaving these deep philosophical ideas right into the AI's structure.
Philosophy and AI, okay.
Yeah, specifically dynamic ontology, epistemology, and phenomenology. The whole point is to create machines that can work directly with meaning, grasp context, and actually handle ethical questions.
So different from most AI we see now.
Very different. Most current AI works a lot on statistics, finding patterns. Sophimatics wants AI that acts and reasons more like us, like humans. It puts genuine understanding and reflective thinking front and center. Philosophy becomes part of the blueprint.
It's not just about the right output for an input then.
No, it's about the process,
Yeah.
how the system generates meaning itself.
Okay, let's unpack this.
Yeah.
Sophimatics sounds like it's built on some really foundational, almost, I don't know, radical ideas for AI. We're talking philosophy, which, isn't usually item number one on a tech spec sheet.
Right.
So what are these philosophical bits exactly? And why are they so vital for building, as you say, wise AI? What problem are they actually solving?
It's a really key question because these elements are what set Sophimatics apart. Think about a typical AI today. It might be brilliant at one specific thing, right?
Sure.
But shift the context just a little bit, and suddenly it falls apart.
Yeah, I've seen that.
That's where dynamic ontology comes in. It's about making the system super adaptable to what's around it. Vernon and Furlong talked about this way back in 2007.
Huh?
They basically said, for an intelligent agent to really work in the messy real world, its internal map, its understanding of reality has to change over time. It needs to add new data or maybe even shift how it connects existing ideas.
So it's constantly updating its own world model.
Exactly. Without that, a machine would be stuck, only able to deal with situations it already knows. It's not just learning facts, it's revising its fundamental grasp of the world.
So this isn't just about an AI getting new data points. It's about fundamentally reshaping its internal picture of reality based on what it experiences.
Precisely.
Wow. That seems like a huge step up from current systems that often get tripped up by anything outside their training data. What kind of real-world problems does that tackle?
Well, think about a self-driving car. Imagine it hits some totally new, weird traffic situation it wasn't programmed for. With dynamic ontology, it could potentially reassess its whole understanding of road rules, maybe even driver behavior, right there in real time. It could adapt its internal model instead of just, hitting a default error state. It's about being resilient, handling true novelty.
Okay, that makes sense. What's next?
Next up is epistemology. Now, this isn't just about getting knowledge. Current AI does that. It hoovers up data.
Right, loads of data.
Epistemology here is about the AI's ability to critically revise what it knows based on the context. Vernon and Furlong again stressed this. Reflective knowledge can change or even throw out existing knowledge.
So it can realize it was wrong.
Yes, and that's absolutely crucial for an AI to stay relevant and operate intelligently in a world that's always changing. Knowledge isn't fixed, it evolves, and a truly smart AI needs to evolve with it.
So dynamic ontology reshapes the world map. Epistemology lets the AI say, hang on, what I thought I knew might be off here, or maybe just plain wrong in this situation. I need to update that core understanding.
You got it. It's a powerful self-correction loop.
Much more nuanced than just piling up more data.
Exactly.
Okay, and the third pillar. You mentioned phenomenology.
Yeah.
How does that handle something so human, like intention or subjective experience?
Right. Phenomenology. This brings in two key things: intentionality and subjectivity. Intentionality means the AI can grasp purpose.
Purpose, how so?
Well, it understands that when a human says something, it's not just words strung together. There's an intention behind it. Maybe they're asking for help, expressing frustration, whatever.
Okay.
So the AI can interpret the context and respond in a way that actually fits the user's underlying goal, not just the literal words. And this is huge because it opens the door to responding to ethical concerns. things purely statistical systems tend to just ignore. And then there's subjectivity. This implies that the AI's knowledge isn't rigid. It can be adapted to specific values or a unique situation.
Like tailoring advice.
Yeah, imagine an AI giving medical suggestions. Instead of just probabilities, it could consider a patient's personal priorities, their values. That's subjectivity.
Interesting.
So putting it all together, adding phenomenology, is about trying to create a system that doesn't just do a task, but does it intelligently and ethically with some grasp of human purpose.
That ambition, grounding AI in philosophy, it sounds like a massive task. I imagine some listeners are thinking, okay, conceptually interesting, but how do you actually build that? How do you code philosophy? The sources mention hybrid symbolic connectionist architectures. Is that the nuts and bolts of it?
That's exactly where the engineering comes in to meet the philosophy. This hybrid approach is the strategy for tackling the weak spots of today's large language models, the LLMs, which, as we said, mostly run on statistical correlations found in huge data sets.
Okay, hybrid. What does that mean in practice?
It means combining the best bits of two different AI worlds. You have neural networks, that's the connectionist part. They're great at spotting patterns, generalizing, that sort of intuitive stuff.
Right.
And you combine that with rule-based symbolic reasoning. Think of it like traditional logic, step-by-step deduction. Jiang and others, writing this year, 2024, showed how these two sides can work together, kind of in sync.
How so?
The connectionist side gives the AI its flexibility. It lets it switch smoothly between just recognizing patterns statistically and what they call deep recognition, which involves meaning.
And the symbolic side.
That's what lets the AI build complex ideas needed for multi-step thinking. Things like setting goals, understanding intentions, keeping track of context.
So it's like blending intuition with logic, combining the pattern matching power of neural nets with the structured reasoning of, say, older AI systems. What can these hybrid systems do that maybe surprise us that current LLMs just can't, even with all their training?
Well, it's potentially a game changer. Think about why something happens. Current LLMs might tell you X often leads to Y because they've seen that pattern countless times.
Yeah, correlation.
Exactly. But they typically can't lay out the logical steps, the actual causal chain of how X leads to Y, or explain why they believe that connection exists beyond the stats. Zhang and his colleagues point this out as a key advantage of hybrids. Current neural nets often lack that clear causal trace needed for proper explanations, for ethical checks, or even reliable planning.
So the hybrid can actually show its work.
Pretty much. By mixing neural nets with symbolic logic, these systems can potentially trace that causal path. This means they could explain why a decision was made, not just what it was. And that's huge for things like auditing an AI's ethical choices or figuring out why a plan went wrong.
Okay, that transparency is critical.
Definitely. Plus, these hybrid systems might handle ambiguity better. Instead of just picking the single most likely meaning, they could hold on to several different interpretations of the input at the same time.
Really, multiple interpretations.
Yes, and then compare them based on, well, how relevant they are, whether they fit the system's understanding of the world, its ontology, and even their ethical validity. They call this situational reasoning. Zhang et al. Argued this gets machine decision-making closer to how humans actually think. So the big goal here is to build cognitive architectures that are tough and adaptable, like neural nets, but can also think abstractly, generalize better, and, importantly, hold on to meaning throughout a task, something current LLMs sometimes struggle with, losing the plot midway.
That sounds like an AI that could actually tell you why it did what it did, not just report the outcome.
Yeah.
How does Sophimatics manage that level of transparency and, well, reasoned judgment?
That's a really crucial piece. Sophimatics, thinking of it as computational wisdom, explicitly models intentionality. It aims for a truly collaborative reasoning process with humans.
Collaborative reasoning, how?
Well, think about standard reinforcement learning. An AI tries stuff and gets a number score, good job, bad job.
Right, points.
Sophimatics aims to define reward differently, using logic. This lets it build ethical guidelines and shared goals right into its decision-making framework.
Okay, so reward isn't just a score, it's a logical statement about what's good or right.
Exactly. And Jeha and Rushby suggested back in 2020 that this shift allows an AI to explain what it chose to do and why, where the why is a specific, defined intention. This makes communication and teamwork between the AI and humans much easier.
I can see that.
Plus, these logical reward structures naturally help the AI generate clear, plain language explanations to justify itself.
That has big implications.
Oh, absolutely. What's really fascinating here is that this could allow AI systems to work much more more effectively in really sensitive fields, law, medicine, education, places where why an action was taken and whether it's acceptable is just as important as the action itself.
So the aim isn't just getting an explanation out, but using that logical reward to actually improve its ethical reasoning over time.
Yeah.
That feels like a major step for AI accountability.
Precisely. Logical reward specifications also feed back into learning better strategies. Jaha and Rushby argue that defining reward logically creates these feedback loops that refine the AI's approach over time. It learns to make choices that we, or our established moral standards, would consider best. The key is translating ethical standards into logic the machine can actually reason with, aligning its computation with human values and intentions.
This feels like it's reaching for something much deeper than just making AI smarter. It sounds more like aiming for wise AI. You mentioned Aaron Sloman earlier, talking about generative explanations. What was he getting at, and why is that idea so central to Sophimatics?
Aaron Sloman, yeah, he made this really insightful point way back in 1978. He argued that just looking at equations or statistics, the reductionist approach common in AI and even neuroscience, fundamentally can't answer the deep, reflective questions about how human thinking works.
Correlation isn't causation, basically.
More than that. He said correlation alone doesn't lead to reflection, to understanding why. For an AI to be genuinely wise, it needs more than patterns. It needs explanatory strategies that reveal the actual mechanisms behind thought, action, emotion. Kind of like how generative chemistry doesn't just list molecules but explains how they form from atoms.
Okay.
And a core strength claim for Sophimatics is that its mental architectures are designed to be reflective. They don't just execute tasks, they can reason about those tasks, evaluate how they did, and even change their own strategy based on that self-assessment.
So current LLMs hit a wall here, too.
Hmm.
They can generate text that sounds like an explanation, but they don't truly grasp the why behind their own output.
Well, this definitely raises a big question about the limits of current AI.
Yeah.
Sloman's point was that statistical data, equations, they just don't give a machine the tools it needs to examine and improve its own internal workings.
It can't look under its own hood, so to speak.
Right. To do that, machines need to be able to manipulate representations of processes, test what-if scenarios, counterfactuals, and understand causal links. LLMs, from this perspective, can't achieve true understanding because they're fundamentally unaware of the causes driving their outputs. They're masters of detecting statistical patterns, yes, but they don't know how or why an output emerges in a way that shows real comprehension.
That's a crucial distinction.
Sloman argued that if we want to build human-like minds, we need these generative explanations. Machines need to be designed with what he called possible minds architectures that can simulate alternative scenarios to judge their own performance. Real intelligence, he thought, involves reorganizing your own understanding, constructing these possible minds.
And Sophimatics provides a way to build that.
Well, if we connect it back, the Sophimatics framework, with its dynamic memory, ontology, and intentionality, aims to provide the tools for exactly this kind of reflection and self-modification. It gives the AI the components to potentially manipulate and reflect on its own internal state.
Okay, this is definitely venturing into some really complex territory now, higher forms of consciousness. That sounds almost like science fiction. How does Sophimatics even start to approach something like that?
It's certainly pushing the boundaries, no doubt, but the approach is intended to be grounded. Sophimatics tries to extend AI theory to model aspects of consciousness that go beyond what typical neural networks focus on.
How so?
Volkova, in recent work from 2025, suggests that human-like conscious processing involves integrated reflective systems distributed over time. These are exactly the kinds of elements Sophimatics tries to capture with its layered memory and intentional modules.
Layered modules.
Yeah, the idea is that these higher-order reflective layers allow for recursion. The system can essentially think about its own thinking.
Metacognition for AI.
Sort of, yes. It's not just running a program. It can potentially review its own internal reasoning, spot biases or logical flaws, maybe even adjust its approach based on that review.
And the integration part.
An integrated system, like the proposed memory and context module, allows it to assess its outputs and reason in ways that might relate to self-awareness and understanding. Volkova also touches on the subjective side of experience. She argues that phenomenology provides tools to model the qualitative, subjective feel of an AI's experience.
Subjective feel in an AI. That's a big claim.
It is. The idea is, since the system takes in sensory input and produces actions, these need to be linked in a continuous flow, from situation through intention to action. Now, actually, modeling self-consciousness computationally, that remains incredibly hard. Huge conceptual, huge computational hurdles.
Understood.
But Sophimatics offers at least a direction, one focused on this ethical reflection and interpretive reasoning. That makes it quite different from standard computational approaches that usually steer clear of these, well, very human-like qualities.
So wrapping this up, what does this all mean for us? Clearly, this isn't just about building slightly smarter tools or more efficient algorithms, is it? It feels much more fundamental.
You're absolutely right. It really represents a potential profound shift in how we think about and develop AI. Sophimatics aims to move beyond just finding patterns in data.
Right.
It's trying to build systems grounded in meaning, in context, in ethics, systems capable of a kind of understanding that fosters reflection and self-improvement. It's about creating AI that doesn't just do things, but has a deeper grasp of the why and the how.
Which could lead to.
Well, hopefully true collaboration, ethical decision-making, especially in those really complex areas where humans operate.
So a final thought for our listeners to chew on. As AI gets woven ever deeper into our lives, what kinds of new ethical questions or maybe collaborative possibilities emerge if these systems are actually designed to understand the why behind what they do instead of just the what?
Yeah. What would it really mean for us, for society, if our intelligent machines could, perhaps one day, genuinely be considered wise?